So we will wait for some time and just observe whether the rest of participants should join. So we have only 12. So I think mm, we'll wait for some time, no? For 5 minutes we will wait. So just check how many students will join. So whether you have completed your assignment or that is going on, or within 2 days you didn't observe anything, right?
नाही करतोय सर कंप्लीट.
ओके. नाही, 2 दिवस आता गणपतीमुळे कदाचित शक्यता आहे की थोडस पेंडिंग राहिलं असेल. पण ते तुम्ही करून घ्या, कारण ह्या आठवड्यामध्ये आपल्याला अचानक फ्रायडेवरून अचानक मंडेचं लेक्चर मिळालं, त्यामुळं आपण टाइम टेबलमध्ये ऍक्च्युअली तसं दिलंय. त्यामुळे ह्या आठवड्यात नंतर लेक्चर व्हायचं नाही. त्यामुळे मागची असाइनमेंट आणि आज आपण देऊ ती असाइनमेंट ते दोन्ही कव्हर करा त्या वीकमध्ये. म्हणजे मग तुम्हाला मी मागे म्हटलं तसं बघूया. म्हणजे जर नवीन टाइम टेबल नुसार जर कॉलेजने एखादी टेस्ट वगैरे ऑर्गनाईज केली तर मग आपण तशी टेस्ट घेऊ. परंतु एक 5 मिनिटामध्ये स्टार्ट करूया. अजून कोण राहिले पहा जरा, नेहमीचे जे असतील ते ग्रुपवर टाका. 14 are there, na? So on Friday, I think there were 15 students participated, right? And I have told at that time also that please mention the name of those students who have not attended the lecture. So that is the responsibility of CR. So who is CR? Okay, who is the CR of our class? Analytical.
सर राज काकडे.
Raj Kakade. Then Raj Kakade didn't send attendance. Actually, yesterday college has organized one hands-on training regarding this, but they are told that they add auto attendance option they have already done. Hope so. Whether they have done such kind of setting, additional setting is required actually, and they have told that they will arrange auto setting. We will check who are absent, and even though they have a record in that setting, how many times you have attend the lecture. That is nothing but suppose there is any kind of internet problem, then you left, then again you have joined. So exact detail yesterday they have told us that such kind of detail is there. So we remember maybe from today college have such kind of information with respect to each and every student, that how much time that student have attended that lecture, when he has left or she has left, and we will check class. So no doubt there is a always internet flexibility, so there should be chance to interrupt the lecture. But we remember immediately you can try to rejoin the class. Okay. So such kind of information is required, because why I am tracing on this point, because not only college but also Samstha has we send the information to Samstha at every day at 4 p.m. after completion of whole lecture, and that information will be collected and sent to government. So that is a big serious issue. So we remember that how many students will that attend the lecture. That is also very important. So those who are not present, So whether Kakade is there or he was also not mm, attend the lecture. I think he was also not there, na? So please open your face.
Yes, sir.
So hi there. Okay, one is added. So where is the CR? If CR is absent, then how the rest of the things are going on? So we will take responsibility now today to take the snap of attendance. So those who are having the very good internet connectivity, that should take the photo of attendance. So on Friday also he was not there, na?
हॅलो सर त्याच्यासाठी काहीतरी प्रॉब्लेम झालाय मेडिकल प्रॉब्लेम आहे ते तो तो
ओके,
येत
ओके,
नाहीये
ओके. हां, मग त्यांनी मेसेज टाकायचा. मी परवाही म्हटलं, की तुम्ही ग्रुपवर मेसेज टाका. कोणाच्या अडचणी असतील ना, डेफिनेटली असू शकतात. म्हणजे असं नाही, की प्रत्येक जण एव्हरीवन शुड अटेंड ईच अँड एव्हरी लेक्चर अँड एव्हरी डे. देअर शुड बी अ प्रॉब्लेम. बट यू शुड सेंड ऑन WhatsApp group because we are prepared for that. Suppose there are 14 students, why the 3 students are not attended the lecture? So you should give the that reason, na sir, because of this problem I have not attended the lecture in the morning. So we just know that why he was or she was absent to the lecture. Okay. So I think now I don't think that anyone should more increase, because on Friday also there were 15 students, so we can start with our regular lecture. uh, so just whether this TLC or whether this PPT you have seen.
Yes, sir.
Okay, so shall we start?
Yes, sir. Yes, sir.
So just we have to change the date. Today is 24th instead of 23 now. Okay. So on last lecture we have started the different sources of ion sources that are used, because in this topic we have focused on ion sources and mass analyzer and some advanced technique that are used. And that's why within this 15 lecture we will try to see in detail the ion sources, and based on that we have observed the number of instrument with the number of which kind of samples we have to analyze. Now up till now we have seen the 7 different ion sources. Based on that the mass spectrometry has been defined. Now we will see the ion mass spectrometry, which is similar to that of fast atom bombardment spectrometry that we have seen on last lecture. So it is nearly the identical to the fab, except the primary ionizing beam is an ion beam rather than neutral atom beam, because in the fab we have observed that we have used argon or xenon beam. Here we can use ion beam. So that is the only difference between second ion mass spectrometry. Okay. So do you understand? So what is the difference between secondary ion mass spectrometry and fab? Because such kind of questions are asked in bits. Be remember. So cesium or argon ions are most commonly used here. So whatever I have given in the introductory part, that is very important on the point of bits also. So you must focus because I have observed when I have assessed your assignment that you should not write down properly. The question is for 10 marks, then you should write down the things which are very important. Okay, so in that sequence you should write down when I have given the home assignment. So here the basic difference between the fast atom bombardment and secondary ion mass spectrometry is that here we can use ion beam, and that ion beams are of cesium and argon ions. So construction and working. In the construction and working, we have see that the source consists of a cylindrical grid and vertically placed ion gun or filament is there, and argon or cesium gas is ionized by heating the filament to produce monoenergetic noble gas ions. So here the source consists of cylindrical grids are there, and vertically placed ion gun is there, which or filament which is passed from vertical line, and argon gas which ionized by the heating the filaments to produce monoenergetic noble gas ions, and that ion gun can produce the ion beam of having a different diameter ranging from 0.1 mm to 1 mm. The ions are accelerated to the potential of 300 to 3000 electron volt. These ion beams is then bombarded on the surface of sample. So first of all, the neutral gas result in the formation of secondary sample ion by charge transfer interaction between the sample molecules and the primary gas ions. So on the surface of sample, when these ions are bombarded, the formation of secondary sample ions which having a charge. So whatever the charge on the gas ion is there, it can be transferred to the sample molecule. So the interaction between sample molecule and gas ion is takes place, and they can form a molecular ion. Ions formed in the cylindrical grid are then extracted from one end and focused on the target or mass analyzer by electrostatic lens. So here there are slits are there through which, or electrostatic lens are there through which these molecular ions are passed and they are transferred to the mass analyzer. Now, what are the advantages of this? So it is highly sensitive. This secondary ion is highly sensitive. Then the selection of beam diameter permits the rapid transition from smaller surface analysis with a small beam to the large surface area. So on the basis of selection of diameter, they can be transferred very fast or rapidly from small surface analysis to the large surface area. So these are the advantages of this process. Now we can see the thermal spray ionization or surface ionization, that is TSI. It is also called as TSI. So did you observe the difference between the FAB and this one, that only we have to change the ion, and the rest of the thing or whatever the mechanism is there, that is similar to the FAB. So almost it is similar, but instead of gas they can be interact the ions. So initially they can form the ions, and then that ions are interact with the sample, okay, which is already kept on the plate. So that is the basic difference between the previous two ion sources. Now we can see the thermal spray ionization or surface ionization. It is also one of the way to ionize the sample molecule, in which the thermal surface ionization source which is used for inorganic solid materials. So generally this method is applicable for the inorganic solid materials. The samples are coated on a tungsten ribbon filament, and then the filament is heated until the sample is evaporated. So that is nothing but here, first of all you have to take the tungsten filament on which the sample is coated, and then we have to pass this filament in a that vacuum chamber which having a pressure, and then it is heated. So the filament, when it is heated, the sample get evaporated, and that sample which are undergo evaporation, they then undergo ionization. So in this case, on the basis of their mass to charge ratio, the probability of the ionization is predictable and is a function of work function. So here they have used one formula, that is nothing but the ionization potential of sample is E1, work function of filament material is phi, and filament temperature is T. So n plus upon n0 is equal to exponential z phi minus E1 upon kT. So that is a uh, equation, and from that they can find out the probability of the ionization which is predictable. But generally when it is passed to the analyzer through different slits, then again in the detector we have observed their mass to charge ratio, and that's why this formula, it is only for the prediction of the probability of the ionization. So here when we have observed such kind of diagram, here is the sample which is kept on the filament, and there is bombardment of the so the ions which are formed here, coated tungsten, this is tungsten filament, and sample is, when you can heat it, then there is extraction of the ion. This is the lens through which we can pass to the analyzer. So the ionization filaments are there. So these molecules sample undergo ionization, they can form different ions with respect to their mass to charge ratio, and they are accelerated through this ion extraction lenses to the analyzer. So in this way, uh, we have to coat the sample on the filament which is prepared from tungsten, and then we have to heat it this. So what will happen, the sample get evaporated, and further these samples, when they get evaporated, they undergo ionization, and they can form different ions, and on the basis of their mass to charge ratio, they can be accelerated towards analyzer by using these ion extraction lenses. So this is the mechanism by thermal spray ionization. Be remember, when we have see the number of ion source methods are there, so there will be little bit change only that, and we have to focus on that point. And on that basis, they may ask the questions in bits as well as short answer, and only those methods which are very important and commonly used, on that the question is asked for long question. And that's why you have to observe, or you have to tabularize the all these ion sources that we have studied up till now. So it is very easy to remember which part is useful and which is used, which filament is used, which gas is used, and how the mechanism is there. So you have to just summarize within a one full scape page whole this data. So you have to do such kind of thing. So that is very easy to remember the whole chapter within a two uh, um, sheets only. So such kind of some work you have to do after completion of this topic. Okay, so do you remember how this work is carried out? Anyone? Okay, so
No,
it is
sir.
very simple. So you
No,
have to
sir.
imagine those student we have, those having a very good imagination power, then it is very easy to remember. Otherwise it is difficult. So you have to imagine that in the box is there in which the process is carried out, and we have to give the ion sources. So from inlet system you have to give the ion sources. So basic four things are there. Along with that, which part we have to change, so that is the important thing. So in this case, you have to write down that name and what source we have used, how the molecule is converted to the whether it is in solid or liquid to the vapor stage, and how the whether there is use electric field, whether we can use laser technique, so which method we can used, that table you have to prepare. And that's why I have told that this is your responsibility, that you have to prepare, because I will not give it ready made. Because when I was doing these things, I have tried to prepare already, that process is going on, but I will not give to you because you have to prepare. So you have to just prepare one full scope page, and we have to write down the first iron source, second iron source, which is mechanism, because on that way I have given which are the advantages, which are the disadvantages. So such thing you have to write down on your uh, notebook or on that full scope page, so it is very easy to remember. And diagram part, okay. So just we can move further. Just we have to remember that what is the important thing in the thermal spray ionization. Can move further. So any difficulty in this case?
No, sir.
No, sir.
Okay, so we'll move further. So this is the actually drawback of Google Meet, that we have not observed the face of students from left right hand side. So just we have to ask the questions. So that is very easy, whether the presentation is going on or whether there is any kind of difficulties, because when the your faces I have observed, then it is very easy to understand whether there is any kind of difficulties there. So actually that problem is also we have discussed yesterday. So they will definitely give solution within 1 2 days, or probably after completion of lecture, I will go there to ask them to solve such kind of problem. So now we'll move further. Electron electrospray ionization, ESI. Those methods which are very very important, and this is used nowadays. That is nothing but with respect to the analyzer, because there are the when you can going through any instrumentation, we have observed the name of ion source and analyzer. They can combine that to name, and that technique is used. So electron spray ionization along with quadruple analyzer, such kind of technique is used nowadays. So this is a very very important procedure. And the next part, that is the multi, that we will see, that these two methods are very very important, be remember. So these methods, these two are used nowadays in all instruments, so that's why these are very very important. So in that sense, this is a modern mass technique, okay. It is a soft ionization technique. So why it is soft ionization technique? Because the molecular ion do not undergo fragmentation. So at initial stage, there is no any kind of molecular fragmentation is takes place. And that's why it is a soft ionization. So it is why it is very useful. Mostly in the biomolecule, it is very very important. So it is used to determine the molecular weight of proteins, peptides, and other biological macromolecules. So that is nothing but for the determination of biomolecules like proteins, peptides, which having very high molecular weight, that can be determined by using ESI. So mostly they can be used for analysis of non-volatile, large and polar molecules. So we know that proteins, peptides linkages are very large, it having very large molecular weight, and we have to determine that. So that can be find out by using the soft ionization technique. It is very very sensitive, and almost more than 1000 molecular weight that can be useful, and its sensitivity is very high, and it is reliable tool for studying. And we know that in first lecture we are already focused on the Nobel Prize with respect to the this mass spectrometry. In that we are already told that in 2002 the Nobel Prize in chemistry was awarded to John Bennett Fenn for the development of electrospray ionization of biomolecule, along with the Japanese scientist for Maldi also. So that is the combined award of Nobel Prize in Chemistry. So from that, one partner, that is John Bennett Fein, who has received the Nobel Prize for the development of electrospray ionization of biomolecule. Mostly for proteins, he has focused on uh, the molecular weight determination, and that's why he has received the Nobel Prize. And along with that, MALDI, that is the next procedure is there, so that we will be also focused on this. Now, we'll see the construction and working of this electrospray ionization. So the method generated ions from the solution of a sample by creating a fine spray of charged droplet. So that is nothing but there is a solution of sample. We have to pass through the column, and then there is a fine spray at the that chamber, so that can be gives a fine spray of charged droplets that can be passed in the chamber. Now, the solution of sample is pumped through a fine charged stainless steel capillary needle at a rate of few microliter per minute. So that is a fixed rate. We have to pass this solution is pumped through a fine charged stainless steel capillary needle. That is a very fine column is there, and through that column we have to pass this one. So needle is maintained at a high electric field, that is several kilovolt, with respect to the cylindrical electrodes, and the liquid pushed itself out of the capillary as a mist or aerosol of very fine charged droplets. So here, in a set of aerosol droplet which is produced by processing involving the formation of Taylor cone and jet from the tip of this cone. So here through column we have to pass the uh, solution, and above and below that there is electric field is there, so that can be maintained with several kilovolt, and that is cylindrical electrodes are there that are covered, and the liquid is pushed itself out of the capillary as air. So due to the such kind of pressure, it can form in the form of droplets. These charged droplets, which are then passed through the dissolvating capillary where the solvent is evaporated. So from other end, we have to use the solvent. Mm, so that is nothing but when we can pass this. So because there is solution of the sample, right? So when we can pass through the dissolving capillary, where this solvent of the sample get evaporated because of the vacuum and pressure, and attachment of the charge to the analyte molecule is takes place. That is nothing but in this case the solution, when it is passed through this very fine capillary and it is in the form of aerosol, so these charged droplets, when it is passed through this dissolvating capillary where the solvent get evaporated, and only the analyte is remain, because it having high molecular weight as well as high boiling point. And that's why generally the solvents which are used, which having the less boiling point, on previous lecture we have already told that generally for mass I have used methanol as well as acetonitrile. So mostly I have prefer methanol because corresponds to that is available with us, so we can observe how it is, how the compound is completely soluble, and just we have to take the 2 milligram or less than 2 milligram sample is sufficient for carry out the mass analysis. So dissolvating capillary uses warm nitrogen gas as a nebulizing gas. So we have to use nitrogen gas through this dissolvating capillary which nebulizes, and the dissolvating capillary is maintained under high pressure, and that's why the when it is coated or cylindrically, the sample is passed through that one and the solvent get evaporated. So as the droplet evaporate, the analyte molecule come closer together, and these molecules become unstable as the similarly charged molecules come together. We know that when solvent is evaporated, the only analyte molecules are left, so they can become close, and because of the instability of like charges come together, they explode once again, and this is called it as coulombic fission. So because of when they are coming very positive charge come together, so there is repulsion is takes place, and they can again explore. And this process repeated until the analyte is free from solvent and only single ionic form is not available. And then once they can form in the ions, because of the slit, they can be accelerated. So from other end, they can be moved towards the mass analyzer. So the process is repeated number of times till we remove whole solvent which is surrounded to the sample molecule. So in electrospray process, the ion observed are quasimolecular ions that are ionized by addition of protons like hydrogen ion to form M plus H ion, or other cation like M plus Na or M plus, even some case silver is also there, but mostly we can use sodium. So other cations such as sodium ion M plus Na, or removal of hydrogen M minus Na, M minus H hydrogen ions. So such kind of ions are observed, and that can be accelerated towards the mass analyzer. So here furthermore, the multiple charge ions are often observed, and these ions are even electron spacing, indicating the electrons have neither been added nor be removed. So whatever the multiple charge ions which are there observed, these ions are even electron species, indicating that electrons have neither been added or removed. So we have observed, so only the positive charge ions that are moved towards the analyzer, while rest are there escape out from the outlet. So this is the very important thing in the mechanism of this ESI. So this is the spraying nozzle. This is power supply. This is very fine capillary. So Taylor cone is there through which this charge parent droplet is come out. So this is analyte molecule. So observed. So these are the under pressure. So through which the solution of the sample is coming, and through this very fine nozzle they can be comes out. And here the charge parent droplet is there. So solvent evaporation takes place because of this electric field, very high voltage, and then this very large analyte molecule, the evaporation of solvent is takes place. So it going on shrinking, it going on uh, reduce its volume, and its size is decreases here because of the removal of solvent. And by coulombic fission, because charge ions were coming together, there is repulsion is takes place, and they can form fission. And here the charge pregnancy droplets, they can be removed. So here when they coming together, they can undergo fission, and they can observe further small particle ions. So these pregnancy droplets are there, and now these remove the solvent, and they can accelerate it towards this mass analyzer. So in this way, the mechanism of electron spray ionization is takes place. How the ionization is takes place, that can be explained. Now there is also one more diagram to this is the actual diagram you should write down in exam. This is very easy. Along with that, same diagram in colored form we have observed. This is the analyte fluent flow. This is the syringe pump, that is nothing but column. We have to syringe through this liquid chromatography. We have to inject the sample solution. This is the capillary. Spraying needle is there, so it having the atmospheric pressure. So automatically the sample solution is move over here, and then through this nozzle, analyte or solvent droplets, they are sprayed, and they are in the form of droplets. Okay, because of the very high pressure. And these droplets, they are passed through over here. The solvent is evaporated, and because of this nitrogen gas flow, again only the ions can move through this transfer capillary. Because of this nitrogen flow, uh, again the positive charge ions, when they are come together, fission is takes place, and solvent get evaporated. So here maximum solvent get evaporated, and whatever the very small amount of solvent is there, so that only ions coming in this cone. And once they are coming, because of positive charge or like charges come together, there is a fission is takes place, and they can pass through this channel. So this is a transfer capillary, and the nitrogen gas is surrounded by nobilization. And here vacuum is the skimmer, so it can be that is nothing but they are the slit, and then it is moved towards the mass analyzer. So same kind of spray needle tip tailor cone, just in the form of colored. We have observed such kind of solvent evaporation, and it is reached to the Rayleigh limit, that is nothing but size is reduced. So analyte molecule is converted to a smaller one, then it undergo fragments. So like charges, there is a repulsion, so it undergo coulombic explosion to undergo fission, and we have observed the small ions, multiple charge droplets are there, and then it can remove the solvents, so process, and we have observed the analyte ions only. So this blue color positive blue color circle ions are nothing but the analyte ions, and that are surrounded by the green solvent. So we have observed this very well, that the green color is the solvent system, and here only the analyte ions can be passed through the this cone counter electrode, and they can pass through the analyzer. So in this way it is very easy to remember, or even though you can draw either this or this diagram to understand the or to give the mechanism of electron spray analyzer. So did you understand this procedure?
Yes, sir.
Huh.
Yeah.
So we have to prepare the solution. So this is a ray diagram. It is very easy to imagine how this syringe, actually we have to prepare the solution, and we have to take in syringe and pass through the this syringe pump or liquid chromatography. Generally what will happen, when we can take any sample, the purification is takes place, and simultaneously that liquid chromatography, it is attached to the mass spectrometry. So LCMS is nothing but at the same time when we can use sample, it undergo purification as well as they can further undergo the molecular weight determination. So that procedure takes place simultaneously, and that's why such combo instruments are nowadays available in the research area. Okay, so this is the procedure which is used for the ESI. Always the question is asked on ESI, MALDI, chemical impact. So there are some common FAB. There are some common methods are there which are used, and question is asked for a number of times. Now the mechanism of ionization in ESI method. So charge residue model, that has been explained. So it is nothing but in charge residue model, it suggests that electron spray droplet undergo evaporation and disintegration cycles, and with each initial droplet leading to the multitude of much smaller daughter droplets. So from parent droplets it converted to the daughter droplets, and each final daughter droplet contain an average one or less molecule of analyte. When the last solvent molecule evaporate from such a droplet, the analyte molecule is left only, and with the charge, that is the drop, that is nothing but the whatever the solvent is present at the last, that is also removed, and only the analyte molecule having the charge ion is observed. So this is the actually method which is takes place in the uh, electron spray ionization technique. So electron spray is similar or very simplify the interface for transferring the ions from solution phase to gas phase, because whatever the droplets are there which is surrounded by the ions, they can be evaporated, and only the ion in the vapor stage is observed with positive charge, and they can be passed to the accelerator. Now how the sample is prepared? So there are two ways. One is positive ion mode and negative ion mode. So in the positive ion mode, we use polar solvents such as water, methanol, acetonitrile. And I have told just now that for organic purpose, we generally use methanol and acetonitrile. Okay. So first they can prepare acetonitrile if the compound is not soluble, but whatever the bulky compounds or biological active compounds which having high molecular weight, all are soluble in the methanol, and that's why they can use methanol instead of acetonitrile. Now some additives are also there. That is nothing but formic acid. Some acids they can be used. So here formic acid, trifluoroacetic acid, sodium acetate, sodium ions, silver ions, etc. can be added. So why they can be added? Because the acid help to protonate the analyte to form M plus H ion, and all these things undergo evaporation, so that not remain at the last stage to enter towards the or transfer towards the analyzer. So here sodium ion and silver ion normally coordinated to the Lewis basic site in the analyte, which is form M plus Na. So here when such kind of ions are attached, now the molecular weight has been changed. uh, I think two lecture back I have already told that we have observed M plus Na peak. So I have taken so many mass spectras in which I have observed M plus H and M plus Na peak. Generally, for organic point of view, we can focus on M plus H and M plus Na peak, and when they are present, then we can confirm that our compound is having the exact mass. So we can use such kind of peak are observed. That is nothing but 22.9898 4 digit. We can observe the molecular weight. So we have to add this in your molecular weight of compound. Then such kind of peak is observed that indicate it is M plus Na, and hydrogen we can observe M plus H. So for negative ion mode, mostly the halogenated solvents are commonly used, and concentration for this ESI technique, typically we use 2 to 10 ppm solution is sufficient. So that is nothing but when your sample is in the form of solid, uh, 2 milligram is more than sufficient. They can use very less amount, and in the ppm level they have prepared the solution. So very less amount of sample is required, but only thing is that it is not recovered. So that is the basic thing in the NMR and mass. So that we have already discussed in the very first lecture. So this is the um, mechanism as well as the preparation of sample is observed. Now, which are the advantages for this? So this procedure has ability to handle the sample with large masses. So as it is applicable for the biomolecular bioactive molecules, mostly for the proteins, lipids, carbohydrates, nucleoside. So such kind of high molecular weight polymers, they can be used or that can be handled very easily by using such kind of MS technique, that is ESI MS technique. So one of the softest ionization method available and has the ability to analyze the biomolecular or biological samples with non-covalent interactions. Again, it having very good sensitivity and therefore used to accurate the quantitative and qualitative measurement. So this is commonly used because it is having very good sensitivity and very useful in accurate quantitative and qualitative, because when I have taken the mass of my sample, then I have get accuracy with, suppose we can say that our weight is 22. So whether it is exactly give or 23, then it can give the weight of 22.9595. So that is nothing but they can give accuracy up to the 4 digit. And that's why the mass is very important in research also. They can focus when we can submit any paper along with NMR C13, you must submit the mass. So nowadays instead of IR they can focus on the mass. No doubt IR is required from functional group, they can be identified, but it not gives the exact information of compound, and that's why along with H1C13 the mass is required. So what are the disadvantages? So this cannot be analyzed mixture very well, and when forced to do so, results are unreliable. So if there is a mixture of compounds, then it is very difficult to analyze, and they can give some unreliable results. The apparatus is very difficult to clean and has tendency to become overly contaminated with residue from previous experiments. Actually, nowadays when I observe this instrument in NCL, that they can be, after completion of this, they can be passed through that column solvent system evaporation and remove mostly by using the methanol system, because the compounds are dissolved and they can probably try to remove that one. So the multiple charges that are attached to the molecular ion can make confusion in spectral data analysis, and prior separation by chromatographic is required. And that's why I have told in the uh, diagram that LCMS is there, because nothing but generally through column chromatography we have to purify the sample. If your compound is not purified after completion of reaction, just we have to work up and take that sample, then it is very difficult to analyze. So be remember that when you can take any kind of analysis that is H1C13 mass, your sample should be highly purified, single spotted on TLC. And even though it is on single spot on TLC, those who are interested to do the biological activity of that compounds, they should carry out the column chromatography. So the separation or the sample should be passed through the column chromatography, then and then only we can observe a single spot on TLC. And then such kind of sample when we can use for then exactly we can get the weight of our final structure of the molecule. So that's why this is very important thing in this case. So here we can apply this ESIMS system. So protein identification and characterization is used very applicable of this ESIMS technique, studying non-covalent interaction, probing molecular dynamics, monitoring chemical reaction and studying reactive intermediates. So for monitoring also we can use this, how the substrate is converted to the intermediate, how one intermediate is converted to other, and how the change in the molecular weight is takes place. So on the basis of molecular weight we can easily monitor the reaction. So that is nothing but nowadays GC is very old. 20-25 year back only GC was used. Nowadays always there is GCMS is there, so we have to load the starting material so we can observe the spectrum in gas chromatography as well as mass, that is GCMS. And then we can take the reaction mix sample and inject it through the column. Then we can also analyze the which kind of intermediate is formed in the reaction. And it is very useful for the application of chemical imaging, the identification and quantification of hemoglobin variants. It is very useful in the proteins and hemoglobin variants, quantitative analysis, and screening for inborn errors of metabolism. So that is very important ESI, and that's why the Nobel Prize has been given in 2002 to such kind of technique. Now advance in the ESI is also observed nowadays. That is the nano electrospray ionization. So in this nano electrospray ionization, it is called as nano ESI. The spray needle has been made very small and is positioned close to the entrance to the mass analyzer. The end result of this simple adjustment is increase the efficiency, which include a reduction in the amount of sample needed. It is very sensitive, very low flow rate is there, and very small drop size is also there. So this is the charge droplet. Then it reduces size, then it undergo fission to form a small ions. Then it evaporate the solvent, and we can observe the corresponding molecular ion. So if you observe micron diameter of the normal electrospray ionizer and nano electron spray ionizer, so 0.2 micron. So this is 1 micron, then it is 0.2 micron diameter. So that is nothing but this nano spray ionization is nothing but the ionization takes place of the solution of the molecule in the form of very small particle size in the form of nano, and that's why it is called as nano ESI. So this technique is also used in very highly reputed institute only, not for all, but this technique is nowadays also applicable. So this is the somewhat new information for you, that is nano electrospray ionization technique. Okay, so did you understand this? Nano.
Yes, sir.
So this is the only change, that we have to change the ESI by using the nano. That is nothing but we have to use the this spray gun along with some special features. But I didn't actually just yesterday I observed this one, so I didn't collect the information regarding. But you may observe this one to get the nano particle size conversion of the sample solution, and that get exact weight. So that is very important. So this is m by z ratio with this one spectrum is also given over here. So such kind of electrospray ionization technique is carried out. So if you observe in this case, I think only 5 minutes are there, so it is very difficult to start this new method, that is Maldi. Again, it is very big as compared to the um, mm, ESI. So we remember that we will must focus somewhat regarding the this diagram. So you must remember this is very important diagram for understand the mechanism of ESI. Okay, and for this you must draw this diagram, so it is very easy to remember. And this is the syringe pump through which we can sample is loaded, and do this spray needle capillary with atmospheric pressure, the sample solution is move forward, and they can be spray because of the very small diameter is there, so they can be in the form of droplet, they can be sprayed, and that droplet containing the such kind of analyte molecule, and they having the multiple charged droplets are there. And when the solvent evaporation is doing, it undergoes shrinking, that is limit of Regan limit is there, and then because of that only the positive charge ions are come very much close together, so there is positive charge repulsion is takes place, and they can get the Coulombic explosion, and we can get corresponding multiple charge droplet, and they can remove the solvent, and we can get only ions, and that ions get accelerated towards the corresponding analyzer. So number of slits are there further, and they can be removed. So in this way, I think just we have to stop here. Only the 2 minutes are there. So it is better way to discuss further. Okay. So um, so you have to imagine these things. I have already taken one video of this ESI, but within this so in the morning I have prepared the this PPT now, so I have downloaded but didn't upload on this. So probably I will send in the your study material that link, so you will observe actually the working of YouTube. One YouTube is also there, how that can be work, or some imagination part is also there, animation part, how the droplets can be converted, so that you have to observe on next lecture probably. So again you have to remember that you have to open your face when uh, we are discussing, so that is very important thing. And already madam also joined, so I have to only 2 3 minutes with us. So we remember only 16 students, that is nothing but again two students are not there. And just check those who are taking the uh, photo of attendance. Actually that process has been done. Just after completion of my lecture I will observe, or I will go to the OIT department and observe how they can automatically taking the attendance procedure. So those who are left during the lecture, that also recorded over there, and that we have to collect every day in the afternoon session and send to the college, so that we have to observe. And that's why we remember that if there is any kind of internet problem, you immediately join to the class, because that everything is recorded in the process, because they have done such kind of thing yesterday. So or those who have any difficulty, you should immediately send the information on WhatsApp group, so that we have to observe the, or we have to solve that problem. Okay. So if any kind of difficulty regarding this part, you can focus on the your WhatsApp group, or we will discuss on next lecture, because this is very very important. Always the question is asked on ESI. So whatever the part I will focus, or say that this is very important, because when you will observe the question paper previous year, then you can observe ESI is commonly asked. And actually I have uh, used this ESI AMS system for my spectral information, and that's why this is commonly used nowadays in NCL, in different universities. This ESIQ or multi TOP, such kind of TOI, such kind of technique are used. That is the advanced technique that we will see in later on lectures. Okay, thank you one and all, and be there. Madam will start to join that class. Just I will leave myself. Okay, and if any kind of difficulty, then ask me. Okay, thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay, good morning.
Good morning,
Good
ma'am.
morning,
Good
ma'am.
morning,
Good
ma'am.
morning, ma'am.
So this is a new system. The college has provided a link for continuous lectures. So every day there will be 2 lectures. Chavan sir might have told you about this. Okay, the timing will change from 9 to 11. So 11 after you will be free to fill up whatever you want, form or notes or assignment, everything. Okay. Hello.
Yes, ma'am.
Hello, ma'am.
आवाज येतोय का माझा?
Yes, ma'am.
Oh, ma'am. Okay.
Is everybody there? Now let me tell you, this is a Google system and attendance is automatically recorded. Those who have joined, the time of joining, those who have left in between the time of left, तो किती वेळ नव्हता हे सगळं Google will record the attendance automatically. So be careful, and this is linked to college account. So आम्ही काही करायची गरज नाही, हे कॉलेज ऑटोमॅटिकली सगळा डेटा जनरेट करणार आहे. Okay. So be attentive while doing the lectures. 11 after you are free to do anything. So be focused on these 2 hours during your lectures. Fine.
Okay, ma'am.
Yes, ma'am.
Let us start with today's lecture. How many of you have completed the assignment?
मॅम ते फोर्थ क्वेश्चन सापडत नाहीये. फिफ्थ क्वेश्चन.
कुठला?
पाचवा आणि सहावा ते वीक. एक मिनिट सांगते. मॅम derive equation for pH and pOH of salt of weak base.
हा, नाही सापडला. इट इज देअर इन जीडी क्रिश्चियन. तुम्ही बघितलं नाही. काय करायचं मी तुम्हाला सांगते. सोपा भाग आहे तो. जो टॉपिक जो आहे त्या टॉपिकचं तेवढा टॉपिक सेव्ह करून घ्यायचा कॉपी करून. ओके, आणि तो सेव्ह करून घेतला की त्याच्यामध्ये तुम्हाला ते सापडेल. इट इज देअर. ओके, नो प्रॉब्लेम. दोनच पुस्तक आपण अभ्यासायचे. एकच पुस्तक रादर आपण शिकतो या टॉपिक साठी वापरतोय ते म्हणजे जीडी क्रिश्चियन. मॅक्झिमम मी त्याच्यातनं घेते, कारण त्याची लँग्वेज सोपी आहे. तुमच्या अंडरस्टँडिंगला आणि तुमच्या लेवलला ते खूप छान पुस्तक आहे. तर बघा त्याच्यात परत. ओके. सो लेट अस स्टार्ट विथ टुडेज लेक्चर. Is the screen visible?
Yes, ma'am.
Okay. So moving to the next lecture, that is Henderson's equation and buffer capacity. This is very basic thing in buffer, that how to measure the capacity of buffer or how to calculate pH of buffer. And this theory was discussed by 2 scientists, Henderson and Hasselbalch. You can see the spelling. Let me select the pointer. Sorry, this is very small. So Henderson-Hasselbalch equation. This is also called as only Henderson's equation because this name is very difficult to pronounce. Let us study the equation, or let us derive the equation first for acidic buffers. The pH of acid buffer can be calculated from dissociation constant. That is Ka of weak acid and the concentration of acid and salt used. How to derive this equation? The important things you know that for acidic buffer you need a mixture of weak acid and its salt. So their concentration must be known and the dissociation constant of acid must be known. So to start with, let us consider a weak acid Ha which dissociates to give H plus and A minus ions. So this is the first step. On the basis of this equilibrium, the equilibrium constant Ka, which is nothing but dissociation constant of acid, is the ratio of, what is it? Product of concentration of the constituent ions divided by the concentration of reactants, that is RHS minus LHS, RHS divided by LHS. This is the dissociation constant. If you rearrange this equation for H plus, because we want to find out pH of the buffer, we'll rearrange this equation for H plus ion concentration. So H plus ion concentration is equal to K into HA. This will go to left hand side and this A minus will come down because this is multiplied here. So H plus is equal to K into concentration of undissociated acid divided by concentration of the salt. What is A minus? A minus is the ion which is common to salt. Okay, a weak acid is only slightly dissociated and its dissociation is further suppressed by addition of salt. कुठला salt टाकला आपण? Salt of strong base with weak acid. So with weak acid, the salt ion is A minus and the strong X ion is from the salt. So which provides A minus ion. So this salt, because it is a strong electrolyte, it dissociates completely and it produces maximum number of A minus ions. And because of formation of A minus ions, due to common ion effect, because A minus ions are also here, and A minus ions are this from the salt, because of addition of these A minus ions, this equilibrium A minus concentration वाढलं की काय होणार, हा इक्विलिब्रियम लेफ्ट हँड साइडला म्हणजे अनडिसोसिएटेड साइडला शिफ्ट होणार आणि याच्यामुळे तो इक्विलिब्रियम कॉन्स्टंट रिमेन्स अनअफेक्टेड. As a result, the equilibrium concentration of unionized acid is nearly equal to initial concentration of acid. That means this is almost undissociated acid because of common ion effect. What is common ion effect, by the way? In equilibrium, remember? Hello? In equilibrium, see, when this is the sign of equilibrium, when the concentration of RHS is exactly balanced by concentration of LHS, the state in the system is known as equilibrium system. When you are adding salt to it, it will produce A minus ions. There is no question of X because X is not here. Okay, because this is a common ion. Why common? Because it is there in the weak acid also. And as it is produced in excess, to maintain this balance, what will do? The excess A minus ions are now converted into undissociated acid. That means the dissociation of acid will be much less, and as a result of which there is a possibility of change in the equilibrium constant. But remember, it is a constant. Pass ha passes ranar, irrespective of change in figure. So in order to maintain this dissociation constant, see, K जर कॉन्स्टंट ठेवायचा असेल तर हा रेशो कॉन्स्टंट राहिला पाहिजे. मग हा A मायनस वाढत असेल तर त्या प्रपोर्शन मध्ये A ची सुद्धा काय झाला पाहिजे, वाढला पाहिजे. सो दिस इन्क्रीज इज बॅलन्स बाय दिस इन्क्रीज टू मेंटेन Ka कॉन्स्टंट. आणि मग हा Ka जर कॉन्स्टंट राहिला तर H प्लसच्या कॉन्सन्ट्रेशन मध्ये काय फरक पडतो, तर this the unionized acid is nearly equal to the initial concentration of acid. The equilibrium concentration of A minus ions is assumed to be equal to initial concentration of the salt added. म्हणजे जे काय A minus इथे आहेत ते कोणामुळे आले, सॉल्टचे तर ऍसिडचे तर आपण कमी केले, त्याच्यामुळे ते इक्वेशन मध्ये जे दिसतात ते कोणामुळे आलेले आहेत, तर ते या इलेक्ट्रोलाइटमुळे किंवा सॉल्टमुळे आलेले आहेत असा त्याचा अर्थ होतो. म्हणजे ए मायनसचं कॉन्सन्ट्रेशन म्हणजे नक्की काय झालं, तर इट इज कॉन्सन्ट्रेशन ऑफ सॉल्ट. आणि म्हणून आपण हे जे इक्वेशन लिहिलेलं आहे 1, याच्यामध्ये काय बदल केला, एच ए अपॉन ए मायनसच्या जागी एच ए हे ऍसिडचं कॉन्सन्ट्रेशन आहे, बिकॉज यू नो दॅट एच ए इज द ऍसिड टेकन, आणि ए मायनस हे आता कसलं कॉन्सन्ट्रेशन झालं, इट इज द कॉन्सन्ट्रेशन ऑफ द सॉल्ट. फाईन, इज दॅट ओके? Yes or no?
Yes, ma'am.
So moving to the next point. See, now taking log on both sides. ते जे मगाशीचं इक्वेशन होतं त्याच्या दोन्ही साइडचं काय घेतलं आपण, लॉग घेतला. सो log H plus ion is equal to log K plus log salt upon acid. Why there is a need to take logarithm? Because we know that pH is nothing but negative log of H plus ion. Okay. So the next step is multiply both sides of the equation by negative sign. So it will be minus log H plus minus log K minus log acid upon salt. Well, what is minus log of H plus ion? It is pH. What is minus log of K? It is pKa. And I'll make this negative positive. So it will be log of concentration of salt to concentration of acid. And this equation is very important in buffering. Why? Because this equation is called as Henderson's Hasselbalch equation. Because it represents pH and pK, it is for acidic buffer. Okay. So this is the first derivation, that is Henderson's equation for. There are only very few steps. So you can, instead of considering general acid HA and general salt XA, you can derive it for any acid or any salt. फाईन. आणि मगाशी जो अफसानाने प्रश्न विचारला की मॅडम ते सापडत नाहीये, त्याचं कारण काय, तर जीडी क्रिश्चियन मध्ये ते जनरल बेस साठी दिलेलं आहे, BOH आणि BX साठी. ओके. सो you have to consider the NH4OH instead of BOH in that place. Fine. We'll discuss that later. So this is equation for acidic buffer, pH of acidic buffer. It helps in calculating pH of buffer solution if the concentration of acid as well as that of the salt are known. हे जर तुम्हाला दोन गोष्टी माहिती असतील आणि जर तुम्हाला त्या ऍसिडचा डिसोसिएशन कॉन्स्टंट माहिती असेल तर तुम्ही त्या ऍसिडिक बफरचा पीएच कॅल्क्युलेट सहज करू शकता. ओके. फाईन. नाउ द सेम थिंग फॉर बेसिक बफर. कन्सिडर द डेरिवेशन ऑफ पीएच ऑफ बेसिक बफर. वेल, इज इट पीएच फॉर बेसिक बफर? बेसिक बफरला कुठला आयन ऍक्टिव्ह असणार आहे, तर OH मायनस आयन ऍक्टिव्ह असणार आहे. सो consider a basic buffer composed of a weak base, general weak base BOH and a general salt XA. No, sorry, BA. Now what is common? This B is common. Fine. And the dissociation constant for the weak base. Weak base being weak, it dissociates to give BOH gives B plus and OH minus ions. This is weak base. And the dissociation constant is again product of RHS divided by LHS, product of LHS concentration, that is B plus into OH minus divided by undissociated base. Now rearrange it for OH minus ion. OH minus ion is equal to, well, what is Kb? Dissociation constant of the base, B for base. So Kb into undissociated base divided by B plus ion. Now this B plus ion is common in both base and salt. So this B plus मगाशी सांगितलं त्या पद्धतीनं कॉमन असल्यामुळे त्याचं सेपरेशन होईल इथे ऍसिड मध्ये. मग जो काय B प्लस असेल तो कुठनं आलेला असेल, इट इज फ्रॉम द सॉल्ट, दॅट इज BA विल गिव्ह B प्लस अँड A मायनस आयन, अँड देअरफॉर नाउ दिस रेशो BOH upon B plus is considered as ratio of concentration of base to concentration of salt. ओके. म्हणजे आता इथे ऍसिडच्या जागी काय आलं, base upon salt. Well, there is second important thing, because it is the base, there is OH minus ion concentration. इथे काय होतं, H plus ion concentration होतं. So again follow the same steps. Take log on both sides and multiply with negative sign. Minus log of OH minus ion is equal to minus log of Kb and minus log of base, concentration of base upon concentration of salt. Okay. And finally, what we'll get is minus log of OH minus ion concentration is nothing but POH is equal to minus log of Kb is PKb. I will make it plus so that it will be log of concentration of salt upon concentration of base. And so this equation is called as Henderson-Hasselbalch equation for basic buffer. I have done this in 2 slides. The reason is so that you will be having the same scenario. काय काय बदलायचं आहे BOH च्या जागी HA घ्यायचा इथे XA घ्यायचा ओके आणि ऍसिडचे डेरिव्हेशन करायचं दिस इज अ सिंपल थिंग टू रिमेंबर अँड दिस इज व्हेरी इम्पॉर्टंट इक्वेशन इन केमिस्ट्री द ओनली इक्वेशन नोन फॉर पीएच ऑफ बफर अर्थात याच्यामध्ये मॉडिफिकेशन खूप आहेत देर आर मेनी मॉडिफिकेशन विथ कॉम्प्लेक्सिटी ऑफ बफर but this is the basic equation and it is now also accepted equation. Okay. So in summary, the Henderson-Hasselbalch equation for acidic buffer is pH is equal to pKa plus log salt upon acid. Well, what is this salt? It is a conjugate base of weak acid. Okay. So the ratio represents concentration of conjugate base to concentration of acid. Well, what is acid? Acid is a proton donor. What is conjugate? It is a proton acceptor. So the equation can also be written in this form. pH is equal to pKa plus log proton acceptor divided by proton donor. Okay. On the contrary, for basic buffer, it is POH is equal to pKb plus log of salt upon base. Concentration of salt upon concentration of base. So base is there, so this will be conjugate acid. If it is a conjugate acid, this is a proton donor, and if it is a base, it is a proton acceptor. So you can compare the equations in this manner. So this is a slightly comparative slide, and I've written at the end 2 problems. Calculate pH of buffer prepared by adding 10 ml of 0.1 molar acetic acid to 20 ml of 0.1 molar sodium acetate. Yes. How will you solve this problem now? पहिला प्रॉब्लेम मी घेतलाय कुठला तर ऍसिडिक बफरचा पीएच काढायचा आहे ओके पीएच साठीचं इक्वेशन काय आहे नेहमी आपण हे इक्वेशन वापरणार कुठलं तर पीएच इज इक्वल टू पीके प्लस लॉग सॉल्ट अपॉन ऍसिड मग पीएच कॅल्क्युलेट करायचं आहे प्रिपेअर्ड बाय ऍडिंग 10 ml ऑफ 0.1 मोलर ऍसिटिक ऍसिड म्हणजे कॉन्सन्ट्रेशन काय झालं ऍसिटिक ऍसिडचं 0.1 मोलर झालं बरोबर आहे का इज दॅट ओके Yes, yes or no? Fine. हे थोडंसं
10 ml ना मॅम
10 ml होणार 10 ml हा काय झाला दिस इज व्हॉल्यूम आणि 0.1 मोलर म्हणजे काय मोलरचा अर्थ काय असतो 0.1 मोल्स पर लिटर बरोबर आहे बरोबर आहे 0.1 मोल्स पर लिटर म्हणजे 10 ml ला किती आले 1000 लिटरला 0.1 आले तर 10 ml ला किती येणार into 10 divided by 100 okay that will be the concentration of acetic acid well याच्यावर विचार करा थोडासा अजून दुसरा इकडे मी प्रॉब्लेम विचारलेला आहे त्याच पद्धतीनं याचं जर आपण डिस्कशन नंतर करू जे तुम्हाला आता थोडंसं फक्त एक मी हिंट म्हणून दिलेलं आहे की या पद्धतीनं हे प्रॉब्लेम आपण पीएच आणि पीओएच काढू शकतो फाईन This is Henderson-Hasselbalch equation and derivation for both pH of acidic buffer and pH of basic buffer. Fine. Is that okay? Ye lita derivation. Yes or no?
Yes.
झोपली का काय लोक किती आहेत अजून Okay. So this is our equation and पुढे जायचं मग सो नाव मागच्या वेळेला आपण थोडंसं एक बफर मेकॅनिझमचे थोडेसे मी इक्वेशन्स तुम्हाला सांगितले होते नाव यू हॅव द मॅथमॅटिकल इक्वेशन फॉर बफर सो लेट अस मॅथमॅटिकली सी हाऊ बफर वर्क्स म्हणजे नक्की बफर पीएच कॉन्स्टंट ठेवतो म्हणजे काय होतं तर दिस प्रोसेस इज ऑल्सो नोन एज बफरिंग मेकॅनिझम याला काय म्हटलं जातं दिस इज ऑल्सो नोन एज बफरिंग मेकॅनिझम What is buffering mechanism? The amount of acid or base that can be added without causing a large change in pH. बरोबर आहे? The amount of acid or base that can be added without causing large change in pH of the buffer. pH मध्ये on addition of amount of acid or base, if the pH remains constant, then what is the mechanism to maintain the pH constant? That is known as buffer mechanism. And the capacity of the solution to maintain the pH constant is known as buffering capacity of the solution. Okay, buffering capacity of the solution. बघा बऱ्याचदा आपल्याला असं सांगितलं जातं, अरे मी काय बोलतो तुझ्या लक्षात येतंय का? लक्ष कुठे आहे तुझं? आपल्या डोक्यामध्ये वेगळं काहीतरी असतं आणि मग त्याच्यामुळे बाहेरनं सांगणाऱ्यांचं काय आपल्याला कळत नसतं. मग आपण जरा ब्लँकली बघतो की नाही मला कळत नाहीये. मग थोडस जोरात बोललं रागवून की मग आपण थोडस जागवतो, मग आपण फोकस करायला सुरुवात करतो. म्हणजे काय तर तुमच्याकडे कॅपॅसिटी आहे पण तुमचं डोकं बफर झालंय आणि ते बफर आपल्याला थोडस हलवायला लागतं आणि मग त्याच्यामध्ये ती गोष्ट जायला सुरुवात होते. वेल that is this type of procedure. So what is this buffering mechanism? Let us consider buffer solution of weak acid and its salt. Okay, आता हे तुम्हाला माहिती आहे pH is equal to constant, pK कॉन्स्टंटच असतो, log of concentration of salt upon concentration of acid. This factor we have discussed in the last slide. मग आता या सोल्युशन मध्ये पाणी टाकलं. Now see, remember when you add or dilute a buffer, when you add or add water or dilute a buffer, the ratio remains constant. pH आणि हे कॉन्स्टंट आहे आणि हा रेशिओ सुद्धा कॉन्स्टंट राहतो. ऍक्च्युअली pH कॉन्स्टंट नाहीये, हा कॉन्स्टंट आहे and this ratio on dilution remains constant. Why constant? Because on dilution, though this gets dissociated, that is weak acid, the dissociation is monitored by A minus ion concentration आणि म्हणून हा ratio it remains constant, and as this remains constant, pH of the solution remains constant. And so remember very well that dilution does not change the ratio of buffering species. In many experiments, particularly in inorganic experiments, you use phosphate buffer, ammonia buffer. ओके, आणि तुम्हाला सांगितलेलं असतं एक टेस्ट ट्यूब टाका, आपण एक टेस्ट ट्यूब टाकतो, 10 ml टाका, आपण 10 ml टाकतो. ओके, तुम्ही असा विचार केला का की 10 ml टाकल्याने कसं काय कॉन्स्टंट राहिला बफर? ऍक्च्युअली युअर सॉल्युशन मे बी 50 ml or 25 ml or 100 ml, but still it maintains its pH constant. The reason behind this is on dilution, pH of the buffer or pH of the buffering species remains constant. And this is very important to remember that on dilution, pH of the buffer does not change. Now, if a small amount of strong acid is added, on the contrary, पहिल्यांदा काय टाकलं आपण त्याला dilute केलं, pH remains constant. In the second time, if you add strong acid, well, because the acid is strong, it will produce H plus ions. And as they produce H plus ion, it will combine with equal amount of A minus ions. हे कुठनं आले A minus ions? You know that A minus ions are available from the salt. They will combine immediately with the added H plus ion. हे कुठून आले आता? From the added strong acid, the A minus ion will combine, it will form undissociated HA. म्हणजे हा कमी झाला आणि हा वाढला, so that this ratio will be maintained constant. And as this ratio will be maintained constant, or even if there will be a small change in the ratio, the pH of the solution, the change in pH is very small. Okay, when you add, see, 1 ml of hydrochloric acid to a buffer, acetic acid buffer, say for example, the change in pH is 0.05 units. किती? म्हणजे जर त्याचा pH असेल 3.7 तर त्याचा pH किती होतो? 3.065. This is mathematically calculated from Henderson's equation. And this 0.05 change is very small, which can be neglected. And in that way, we can say that pH of the buffer remains constant. Okay, so on addition of strong acid, pH remains almost constant, or there will be a very small negligible change. If small amount of base is added, आता base add केला की काय तयार होणार? NaOH add केला, it will introduce OH minus ions. The added OH minus ions immediately combines with HA to form equivalent amount of A minus ion. OH minus ion H बरोबर म्हणजे कोणाबरोबर react होणार? H plus बरोबर react होणार. It will form water molecule, and then because it will form water molecule, this A minus ion will increase and this HA will decrease, and so that again the ratio will remain constant and pH will be almost the same, or there will be a very small change in pH of the buffer on addition of strong acid or on addition of strong base. Okay, fine. This process is known as buffering mechanism, and I have used a second word here, buffering capacity. So मग आता असं किती टाकायचं? समजा मी 1 ml च्या जागी 2 ml टाकला. Now remember, I will tell you one thing here. Suppose your solution is NaOH. ज्याच्यामध्ये तुम्ही इंडिकेटर टाकून ठेवला phenolphthalein. What color it will develop? When you add phenolphthalein indicator to NaOH, what color it will develop? Hello?
Pink color.
Pink color. Very good. Okay.
Pink color.
Pink color. When you add, say, to that 10 ml solution of NaOH, if you add 1 ml acetic acid, or sorry, 1 ml HCl, what will happen to that pink color? It will be slightly faded. Okay, त्याचा रंग कमी होईल. Why? Because the added HCl will combine with NaOH and it will form what is known as NaOH plus HCl. It will form NaCl, so that NaOH concentration will decrease and the pH of the solution will certainly change. But now here, if you add 1 ml of acid, the pH will show a very small change, and that change is negligible. Therefore, this mixture is called as a buffer, and NaOH is called as a base only, strong base only, or HCl is called as strong acid only. Fine, this is the difference. So what is buffer capacity? Actually, मगाशीच्या स्लाइड मध्ये मी शब्द वापरला. This is known as buffering capacity. Okay, so what is buffer capacity? The buffer capacity of a buffer solution is a measure to its magnitude, buffer of its magnitude, of its resistance to change the pH on addition of acid or base. So how long this buffer can stand without changing pH? This is the simple language. किती ऍसिड टाकलं किंवा किती बेस टाकला म्हणजे त्याचा pH कॉन्स्टंट राहील. How long it will stand to change in pH, or how long it will resist to change its pH? किती वेळ तो विरोध करत राहणार? That capacity of a buffer is known as buffer capacity. Okay, and this buffer capacity is also known as buffer index. It is also known as buffer value, buffer efficiency, buffer coefficient, or buffer intensity. एवढ्या सगळ्या गोष्टी किंवा एवढ्या सगळ्या वेगवेगळी नावं त्याला दिली जातात. In general, this is known as buffer capacity. It is denoted by symbol beta. And for a solution, this beta, that is buffer capacity, is defined as beta is equal to dCBOH. D means change, delta. Okay, delta तुम्हाला माहिती आहे, आधीची व्हॅल्यू आणि नंतरची व्हॅल्यू. द डिफरन्स इज कॉल्ड एज डेल्टा. Delta C is concentration. BOH, that is that of base, divided by DPH. म्हणजे बेसचं किती कॉन्सन्ट्रेशन टाकल्यानंतर किती कॉन्सन्ट्रेशन बदललं तर करस्पॉन्डिंग पीएच मध्ये काय चेंज होतोय. That is this ratio, which is denoted by buffer capacity. The same thing is true for acid. DCHA divided by DPH. See, I have written it here. DCBOH and DCHA are defined as number of moles per liter of strong base or acid needed to bring out pH change of DPH. DPH एवढा चेंज मिळवण्यासाठी ऍसिडचे किंवा बेसचे किती मोल्स आपल्याला ऍड करायला लागतात त्याला म्हणायचं बफर कॅपॅसिटी. The number of moles required to change the pH by small amount, DPH, by adding number of moles of base or number of moles of acid to the equation. Okay, pH बघा इथे मी इथे निगेटिव्ह साइन दिलेली आहे. The reason is with addition of acid, H plus ion concentration will increase and the pH will go on decreasing. It may be possible that the pH will go to negative sign. So in order to maintain that negative sign, because pH cannot be negative, there is a negative sign here. Whereas you know that pOH is always greater than 7 and there is because it is greater than 7, there will be increase in value, even if you increase the OH minus ion concentration, and therefore no negative sign is required here. Okay, this is simple mathematics. So this formula is plus and this formula is minus. Remember this. So, and that is what I have mentioned here. Buffer capacity is a positive number. It is always a positive number. If it is a negative number, what does it signifies? It signifies that the buffer is not resisting the change in pH, or it is no more buffer because its pH is continuously changing. And so remember, buffer capacity is always a positive number. The larger it is, more resistant the solution to pH change. The greater the value of buffer capacity, the more the solution resistant to the change in pH. Okay, so this is the सिग्निफिकन्स ऑफ बफर कॅपॅसिटी. म्हणजे जे काय आपण बफर बनवतो आहे त्याला कुठेतरी अकाउंटिंग केलं पाहिजे. इन ऑर्डर टू अकाउंट द कॅपॅसिटी, द टर्म विच इज यूज इज नोन एज बफर कॅपॅसिटी और बफर इंडेक्स. फाइन, this is very important term. So next point or next significance, in addition to concentration, the buffering capacity is governed by the ratio of Ha to A minus, that is undissociated acid to dissociated acid, that is salt concentration. The maximum, it is maximum when the ratio salt upon acid is unity. When this is possible? तर बघा, दुसरा सिग्निफिकन्स काय सांगितलं मी तुम्हाला, बफर कॅपॅसिटी पॉझिटिव्ह असते. बफर कॅपॅसिटी जेवढी जास्त तेवढा पीएच चा चेंज कमी त्या सोल्युशन मध्ये दिसेल. आता तिसरी सगळ्यात महत्वाची गोष्ट काय, तर वेन दिस रेशो इन द इक्वेशन, म्हणजे मग तो ऍसिडिक बफर साठी घेतलाय म्हणून मी सॉल्ट अपॉन ऍसिड घेतला. बेसिक बफर साठी काय होणार, इट विल बी सॉल्ट अपॉन बेस. वेन दिस रेशो विल बी 1, हा 1 केव्हा होणार, जेव्हा दोन्ही कॉन्सन्ट्रेशन कसे असणार, सारखे असणार. दॅट इज कॉन्सन्ट्रेशन ऑफ सॉल्ट अपॉन अँड कॉन्सन्ट्रेशन ऑफ ऍसिड इज सेम, देन दिस रेशो विल बी 1. what is log of 1? log of 1 किती असतो? log of 1 is 0. as log of 1 is 0, येतोय का आवाज?
हो येतोय मॅम.
ब्रेक होत नाही ना कुठे? नाही, मला लेट रिस्पॉन्स येतोय तुमचा म्हणून. ओके, सो log of salt upon acid is unity, and when this is unity, log of 1 is 0, so the equation is pH is equal to pKa. This corresponds to midpoint of titration of weak acid. बघा, हे कधी केलंय का आपण? in your TY class, and even if you in your MSc class, I don't remember exactly for MSc, but for TY I know you have performed 2 pH metric titrations. Okay, which are those? To determine dissociation constant of weak monobasic acid, that is acetic acid, you carry out the concentration using pH 4 buffer, weak acid, and burette मध्ये तुम्ही घेता NaOH, you go on titrating, you get nice S-shaped graph. Okay, and then you find out the equivalence point. You say that equivalence point is the point at which there is sudden change in pH. आठवते का? एस शेपचा ग्राफ येतो. फाइन, बघा मी तुम्हाला थोडस रिमाइंड करते. येतोय का व्हाईट बोर्ड? मला बघू देत. प्रेझेंट नाही. आय मी 1-2 मिनिट शेअरिंग स्टॉप करते आणि आपण जरा बोर्ड घेऊया. कुठनं येतो याला बोर्ड? माहितीये का रे बोर्ड कुठनं येतो गुगलला? नो. ओके, प्रेझेंट नाव मध्ये विंडो नाही, त्याला बोर्ड काही येत नाही. ओके, फाइन. सो इफ यू रिमेंबर, आठवतंय का कोणाला एक्सपेरिमेंट वीक मोनोबेसिक ऍसिडचा? बघा, एस शेप, सिग्मॉइड शेप ग्राफ येतो. वेल, मी घेतो आठवतोय का बघा, असा तुम्ही ग्राफ काढला, इथे पीएच होता, इथे व्हॉल्यूम ऍडेड होता आणि मग तुम्हाला असा ग्राफ मिळतो सिग्मॉइड शेप. ओके, आणि मग तुम्ही असा त्याचा इक्वलन्स पॉईंट काढता. दिस इज द इक्वलन्स पॉईंट. आणि मग तुम्हाला सांगितलं जातं की फाइंड आउट द पीएच ऍट हाफ इक्वलन्स पॉईंट. मग तुम्ही इथनं हाफ इक्वलन्स पॉईंटचा पीएच घेता, बरोबर आहे. आणि या पीएच ला आपण काय काढतो तर डिसोसिएशन कॉन्स्टंट काढतो आणि आपण म्हणतो की ऍट दिस हाफ इक्वलन्स पॉईंट pH is equal to pK. So what is the significance of this pH is equal to pK at half equivalence point? The significance is here. At this point, concentration of salt and concentration of acid are exactly same. And as they are same, the ratio is 1. And as the ratio is 1, you can say that pH is equal to pK. And so we find out this pH, and from this pH, calculate the dissociation constant of acid. जर आठवत असेल तर दुसरा एक्सपेरिमेंट केला तुम्ही मॅलोनिक ऍसिड साठी आणि तुम्हाला असे दोन दोन इक्वलन्स पॉइंट मिळतात बघा, आठवते का. आणि मग तुम्ही पहिला इक्वलन्स पॉइंट इथे काढता, ह्या दुसरा इक्वलन्स पॉइंट इकडे काढता आणि दोन इक्वलन्स पॉइंट वरून दोन हाफ इक्वलन्स पॉइंट आणि मग त्याच्यावरून तुम्ही दोन डिसोसिएशन कॉन्स्टंट काढता. इज दॅट ओके? सो द प्रिन्सिपल बिहाइंड दॅट ऑल इज दिस, दॅट in pH metric titration, what is important is the pH value. Fine. And when you represent it the pH value, then you can easily find out the equivalence point for that particular titration. आता याच्यात तिसरा महत्वाचा पॉइंट काय, स्मॉलर द pH चेंज इन सोल्युशन ग्रेटर इज इट्स बफर कॅपॅसिटी. जेवढा pH चेंज कमी असेल तेवढी त्या बफरची कॅपॅसिटी जास्त असते. ओके. So this is quantitative and qualitative aspect of buffer capacity. If you ask to write a note on buffer capacity, everything is there in this slide. In addition, if you go through the book, that is GD Christian buffer capacity or buffer mechanism part, there is that NOH problem solved. You add that or you read that, so it will be a more clear idea for you. मी आता ते इथे सगळं देऊ शकत नाही कारण स्लाइडला लिमिटेशन्स येतात, ते तुम्ही वाचून तिथनं पुस्तकातनं बघू शकता. Okay, so this is buffer capacity. Now coming back to next point, numericals. See, right from the very first assignment I am giving you numericals, and my idea about numericals is very clear. Because you are chemistry students, it is not because I am a physical chemist and all. Remember, because you are a chemist, whether it is physical, organic, analytical, पीएच इज ऑलवेज देअर. इनऑर्गॅनिक मध्ये पीएच असते, ऑर्गॅनिक मध्ये असते, आणि मग त्या पीएचचं तुम्हाला सगळं नॉलेज असलं पाहिजे. अँड आय ऑलवेज insist on solving such type of problems because these are tricky problems. These are useful in all types of chemistry. These are useful in all types of competitive exams also. तुम्ही जर नेट किंवा सेटला किंवा गेटला जाणार असाल तर ट्रिकी पीएच चे प्रॉब्लेम्स विचारलेले असतात. आणि मग तुम्हाला त्या गोष्टी, आणि पीएच चे प्रॉब्लेम हा युनिव्हर्सल प्रॉब्लेम आहे लक्षात, त्याच्यामुळे ते तुम्हाला आलंच पाहिजे. म्हणून पहिल्या स्लाइड पासून मी तुम्हाला हे पीएच टाकते आहे. किती मुलांनी सोडवले मला माहिती नाही, तुमच्या असाइनमेंट मी ठेवलेले आहेत त्या मी बघणार आहे. मी बघत नाही कारण त्या बघितल्यानंतर त्या तुम्हाला परत जातात, माझ्याकडे रेकॉर्ड राहत नाही, म्हणून मी ते सगळं तसंच ठेवलेलं आहे. ओके. आणि मला असं एक्सपेक्टेड आहे की तुम्ही प्रश्न विचारले पाहिजेत की मॅडम हा मला सुटलेला नाहीये, हा तुम्ही मला सोडवून दाखवा, किंवा हा मी या पद्धतीने सोडवला आहे. दिस इज व्हॉट आय एक्सपेक्ट. ओके. बघा, while solving numericals, steps to be followed: reading and understanding of the question or problem. जो प्रॉब्लेम दिला, you read it carefully and understand the problem. काय विचारलेलं आहे, काय दिलेलं आहे. Write the given things. Select the proper equation. त्याला सोल्युशन काय आहे ते शोधायचं. Substitute the data given, calculation and result. This is what I teach to students right from BSc first to till MSc. But many students still are very afraid of solving problems or very afraid of tackling the problems. Unless and until you tackle the problem, you will not get the solution, remember. So don't be afraid. Go stepwise. सोपे सोपे प्रॉब्लेम सोडवा. पुस्तकात सोडवलेले बघा त्यांनी कसे सोडवले ते and then solve. So for that I have taken a very simple problem here. See, what is it? Calculate the pH of buffer solution containing 0.03 moles per liter of acetic acid and 0.1 mole per liter of sodium acetate. pKa of acetic acid is 4.57. This is 12th class problem. 12वीला कुठल्याही सीईटीला किंवा कुठल्याही केमिस्ट्रीच्या पेपरला विचारला जाणारा प्रॉब्लेम आहे. ओके, सो कॅल्क्युलेट pH. First read the problem. Second reading, calculate the pH of buffer solution. So you are expected to calculate pH containing 0.03 moles of acetic acid. So what I have written, concentration of acetic acid taken is 0.03 molar and 0.1 moles per liter of sodium acetate. So well, sodium acetate is a salt, so I have written it as concentration of salt is 0.1 molar and pKa for acetic acid is given, that is 4.57. आणि काय विचारलेलं आहे तर pH विचारलेलं आहे. So my solution for the problem is pH is equal to pKa plus log salt upon acid. Which is this equation? Yes. Henderson's equation for acidic buffer. Okay. When this is acid in the numerator, you can immediately identify that this is Henderson's equation for acidic buffer. So substitute the values. pKa is given 4.57, log of salt is 0.1, concentration of salt is directly given moles per liter, so 0.1 divided by, well, there is no question of volume here, so directly substitute the concentrations, find out the log, add the log. Remember here, add the log value only. Many students what they do is log बघितला की त्याचा anti-log बघायचा. Don't do that. So add the log value, you will get the pH of the solution. And finally, what you have done is represented nicely in the form of result that the pH of the buffer solution containing 0.3 moles of 0.03 molar acetic acid and 0.1 molar sodium acetate is 5.09. So this is the end of my problem. This is very simple thing. If you go stepwise, it is very easy to calculate the value. Okay. Now second format, calculate pH of buffer solution containing 0.25 moles per liter of formic acid. Now which acid is given? Formic acid. So immediately the second thought in your mind should rise that formic acid, whether it is strong or weak. Yes. Weak acid. Okay. So its concentration is given. Only Anupama is giving answer. Where are others? आहे की नाही कोणी? Formic acid 0.1 moles per liter sodium formate. Okay, दिलेला नाहीये. And sorry, 0.25 moles per liter of formic acid and 0.1 moles per liter of sodium formate, and the dissociation constant of formic acid is given 1.8 into 10 raised to minus 4. Okay, so the concentrations are given. Substitute the values. Now direct Ka is given, so find out pKa. pKa is minus log of K. So the calculation in detail I have given, that minus log of 1.8 minus plus log of 10 raised to minus 4. 0.25 log of 1.8 is, and minus log of 10 raised to minus 4 is minus 4. This minus and this minus will be plus, so it is, the answer is 3.75. So 3.75 is the pK of that acid. Substitute the values and find out the pH in the, as explained in the previous problem. So these are simple two stress problems. These I have taken from GD Christian, and many unsolved problems are given there. So what I would expect is try to solve these problems. मी assignment देणार आहे, त्याच्यात या पद्धतीचे काही problems देईल. Okay. So this is use of Henderson's equation in calculation of pH and pKa. Of course, it is very useful in calculation of concentration of salt and concentration of acid. That also I have discussed. See the third problem. This problem is on preparation of buffer solution. ऐकताय का झोपले सगळे?
Yes, sir.
Yes, ma'am. Yes, ma'am.
Okay. So what is my third problem? Third problem is prepare a buffer solution of pH 5. So what is expected is prepare a buffer solution of pH 5 from acetic acid and sodium acetate. pKa for acetic acid is 4.7. The standard value for acetic acid is 4.74. Okay. So what is required? What I have expected to do to prepare buffer of pH 5. Molar concentration of acid required is 1 molar. Molar concentration of base required I don't know. ओके सो मला पीएच माहिती आहे डिसोसिएशन कॉन्स्टंट माहिती आहे एक कॉन्सन्ट्रेशन माहिती आहे अँड आय डोंट नो हाऊ मच अमाउंट ऑफ बेस इज रिक्वायर्ड और हाऊ मच अमाउंट ऑफ दिस सोडियम ऍसिटेट इज रिक्वायर्ड ओके बेस मी म्हटलंय हे ऍक्च्युअली काय असतो सॉल्ट असतो पण मी इथे काय म्हटलं बेस दिस इज कॉन्ज्युगेट ऍसिड सॉरी दिस इज कॉन्ज्युगेट बेस ऑफ ऍसिड सो आय हॅव रिटन इट ॲज बेस सो substitute the value, assume this as x, take it as x and find out the value of x. And then finally write the answer as the ratio required is 1.1 as to 2. That is, if this is 1 molar, you have to take the salt as 2 molar. If it is 0.5, you have to take the salt as 1 molar. Okay? आणि इथे काही गोष्टी म्हटल्यात लॉग इनवर्स दिस इज लॉग विथ निगेटिव्ह साइन लॉग इनवर्स मी मुद्दाम टर्म वापरली नॉर्मली आपण याला काय म्हणतो 0.3 log of x if you want to find out x we immediately say that antilog of both sides मग अँटीलॉगच्या ऐवजी आता आपण कॅल्क्युलेटर मध्ये जे फंक्शन वापरतो ते कुठलं फंक्शन वापरतो लॉग इनवर्स फंक्शन वापरतो सो आय हॅव रिटन इट हिअर ॲज लॉग इनवर्स ओके लॉग इनवर्स मीन्स अँटीलॉग सो फॉर युअर इन्फॉर्मेशन म्हणजे जे कोणी वीक असतील मॅथमॅटिक्स मध्ये त्यांना समजण्यासाठी मी या सगळ्या गोष्टी इथे स्वच्छ शब्दात लिहिलेल्या आहेत सो फाइंड आउट द अमाउंट ऑफ बेस रिक्वायर्ड फायनली व्हॉट इज द सिग्निफिकन्स ऑफ हेंडरसन हॅसेलबॅच इक्वेशन देन काय काय कळलं तुम्हाला हेंडरसन्स इक्वेशन गिव्स इट इज व्हेरी इम्पॉर्टंट इन कॅल्क्युलेशन ऑफ पीएच ऑफ बफर सॉल्युशन it can be calculated from initial concentration of weak acid and salt and Ka are given. बरोबर आहे however Henderson's equation for basic buffer will give the value of सगळे कॅल्क्युलेशन मी ऍसिडिक बफर साठी घेतले आणि सगळे बेसिक बफरचे तुम्हाला होमवर्कला देणार आहे असाइनमेंटला लक्षात घ्या मग सगळ्या बेसिक बफरला तुम्हाला काय मिळणार आहे ऍसिडिक बफरचा पीएच डायरेक्टली मिळतो बेसिक बफरचा काय मिळणार पीओएच मिळणार So from this pH, pH can be calculated by using the equation. Which is this equation? शिकलोय का आपण हे pKw is equal to pH plus pOH or pH is equal to 14 minus pOH or pOH is equal to 14 minus pH. हे कुठे शिकलो आपण इक्वेशन अगदी सुरुवातीला जेव्हा pH आणि pOH शिकलो तेव्हा आयनिक प्रोडक्ट ऑफ वॉटर बघितला at that time we have discussed all these equations. Okay? So in this way, Henderson-Hasselbalch equation is very useful in determination of pH, pOH and buffer capacity of all the buffers which are used in everyday life. मग इथे आपला पहिला पार्ट संपतो कसला पहिला पार्ट संपतो तर आतापर्यंत आपण till now what we have studied is in acid base equilibrium is what is equilibrium, what are strong acids, what are weak acids, what are their properties, पीएच म्हणजे काय पीओएच म्हणजे काय बफर म्हणजे काय या सगळ्या गोष्टी ज्या आपल्याला माहिती असायला पाहिजे त्या शिकलो इथनं पुढे आपला फिजिओलॉजीचा पार्ट सुरू होणार आहे फिजिओलॉजी मीन्स व्हॉट इज द इम्पॉर्टन्स ऑफ दिस केमिकल इक्विलिब्रियम इन बॉडी फिजिओलॉजी ओके आणि म्हणून सगळी केमिस्ट्री आपली शिकली आता इथे आपल्याला बायोलॉजिकल केमिस्ट्री शिकायची आहे इथनं पुढच्या लेक्चरला ओके सो ज्यांना कोणाला शंका असेल किंवा ज्यांना कोणाला समज असेल त्यांनी आतापर्यंतचा पाठ व्यवस्थित तयार करायचा कारण पुढच्या पार्ट मध्ये आपण काय सुरुवात करणार मी अगदी थोडंसं घेतलंय काय तर ऍप्लिकेशन्स ऑफ बफर्स इन बायोलॉजिकल सिस्टीम्स आय हॅव डिस्कस दिस पार्ट द पीएच ऑफ ब्लड इज मेंटेन अबाउट 7.4 in our body. What are the effect of change in temperature on pH? what are the effect of addition of or increased acid or increased base content on the pH of blood, that also we have discuss केलंय का आपण pH of blood मध्ये. So to maintain that pH of blood constant in our body there are two buffer systems. ओके, याच्यातला पहिला असतो तो म्हणजे प्रायमरी बफर सिस्टीम आणि दुसरा असतो तो म्हणजे सेकंडरी बफर सिस्टीम. द डिटेल्स ऑफ दिस आय विल नॉट डिस्कस, पण मी फक्त इथे थोडस पुढे सुरू करून ठेवणार आहे. त्याचं कारण असं आहे की मागचा सगळा भाग आता आपण येणार नाही. आपण आता काय वापरणार आहोत, विल डायरेक्टली यूज द वर्ड्स लाईक ऍसिडिक बफर, बफर कपॅसिटी, this is the pH of the solution, the equilibrium changes, the dissociation constant changes. So everything that we have discussed till now will be directly applied in the lectures henceforth. And for this purpose, what I'll expect from you is that okay, how many of you are there? 16 of you are there. You all are attending my lectures from very first slide. Okay, first lecture has taken on 6th of July, I suppose. And I have supplied all the material to you. जसं जसं माझं तयार होत गेलं तस तशा मी स्लाइड शेअर केलेल्या आहेत. And in the very first lecture, I inform you that go through the slide, go through the reference book and prepare your own notes. So this is till next Monday. What I would expect is go through all the slides and prepare your own notes, because the next lectures will be on physiology of buffers and physiology of and chemistry in physiology, application of chemistry in physiology. For this purpose, okay, prepare your own notes. And well, are there any other problems now? चला अनम्यूट करा, कोणाचे काय प्रॉब्लेम्स असतील ते सांगा, डिस्कस करूया आपण. एक शेवटचे 5 मिनिट राहिलेले आहेत, बिकॉज द लिंक विल बी शेअर्ड ॲट 11 बाय अदर क्लास. ओके, हॅलो,
येस मॅम.
म्यूट करा, अनम्यूट करा, व्हिडिओ ऑन करा, मला दाखवा सगळ्यांचे चेहरे. लेट मी सी what you all are doing. Is there any problem? Discuss all your problems. आनंद सुतारने येऊन फी भरलेली आहे. त्या दोघी मुली आलेल्या नाहीये, त्यांचं काय? ओके, वेल, स्नेहल कुंभार नाही, तिने भरले नाहीयेत. आणि शुभम, त्याने भरलेले नाहीयेत. शुभम राजगे. काय कळलं का आनंद त्यांच्याबद्दल?
नाही मॅडम, त्याला फोन लागत नाही राजगीरचा.
ओके, स्नेहल कुंभार कोणाची मैत्रीण होती ग? नीलम,
मॅम तिला पण कॉल लागत नाही आणि मेसेज पण नाही जाते तिला.
मेसेज पण नाही जाते. बरं, तुमचा क्लास रिप्रेझेंटेटिव्ह कोण आहे?
मॅम राज काकडे मॅम.
कुठे गेला राज काकडे? राज काकडे
मॅडम
लेक्चर
त्याला काहीतरी प्रॉब्लेम झाला मॅडम, त्यामुळे तो अटेंड करत नाही लेक्चर.
काय प्रॉब्लेम झाला? त्याने इन्फॉर्म केलं पाहिजे ना.
हो मॅम.
कोणाला सांगितलंय का? माहितीये का त्याच्याबद्दल कोणाला?
मॅडम त्याच्या मामांचं काहीतरी मेडिकल प्रॉब्लेम झालाय, ते ऍडमिट आहेत काहीतरी, सो हा तिकडेच असतो.